In this video, I will show you how Bitcoin-IPC can be used for agenting Bitcoin payments. AI agents are starting to make payments on their principal's behalf, and Bitcoin is the money you'd want them to use. But paying directly on Bitcoin is slow and expensive, and having an agent in your case is out of the question. Bitcoin-IPC addresses both. Payments run on subnets, fast and cheap enough for an agent to pay per task, while every subnet anchors its state back to Bitcoin. And the agent never holds keys. It operates a user-owned wallet through a policy layer. It can only request payments. Small ones execute. Anything over a cap needs the owner's approval. What I will show you is Claude managing real payments in this way. Deposit, pay, and then prove where the money went on Bitcoin itself. Here I have connected Claude to an MCP server developed for the Bitcoin-IPC protocol. Let's see what we can do. We can ask, for example, what is in my wallet? The MCP server has this ability built in. It can look into your wallet and it shows you your balance on Bitcoin L1 and on all existing subnets. Let's make a payment now. As we said, the model sees no keys. They are protected behind the MCP server. And since this amount that we are paying here is below our cap, the model will not ask for a confirmation. It will contact the MCP server, obtain the key, and perform the payment. As you can see, the model already knows this restaurant because we have used it before. It knows that it's located on subnet 1. It has retrieved all the details and now we are ready to perform the payment. And this is done. The payment has been delivered. Let's now try a different one for an account which lives on a different Bitcoin-IPC subnet. For example, we could try this. Now the model is showing me some various information, and it's telling us that this is a cross-subnet transfer because it knows that this account lives on a different subnet. In Bitcoin-IPC, all cross-subnet transfers are routed through Bitcoin. So our AI model can use this information and prove exactly where our money went and how it was routed. The most interesting is the second payment, which is a cross-subnet payment and was routed through Bitcoin. And we can see here that it landed on this specific checkpoint. This refers to subnet height, and this refers to the Bitcoin block on which this checkpoint was submitted. And we can see all the changes in the balance in the recipient and target account. The agent can also deposit Bitcoin from the Bitcoin L1 chain to a subnet. It will ask us for the confirmation. And now in the backend, the server is creating the correct transaction, which will deposit to this to our address in the subnet. And the tool can check our balance as well. This functionality has been added to Claude as a custom connector, as we mentioned before. The BSL payments here. It can perform various tasks, such as deposit Bitcoin into subnet 1, and for this one, the MCP server knows how to create and submit the correct Bitcoin-IPC transactions to Bitcoin. And also it can perform some transactions like send wrapped Bitcoin between addresses on an L2, for which it uses standard EVM transactions.